What if I told you that reality itself isn't what we think, that the very act of looking at something changes what it is? For nearly a century, we've lived with a haunting paradox called the observer effect, the strange truth that the universe performs differently when there's an audience. But Google scientists have just achieved the impossible. They've found a way to witness the unwatchable, to observe without disturbing. And what they found wasn't gibberish, it was code. The same kind of error-correcting code we use to run web browsers, buried deep inside the fabric of reality itself. We are standing at the edge of a phase shift in human capability. Between now and 2028, the convergence of quantum computing and artificial intelligence will change everything about how we live, how we work, and how we understand our place in the cosmos. We are moving from the era of calculating into the era of dancing with possibility. Tom's following Moore's law. But we've run out of space. When switches get that small, electrons start to tunnel through barriers they shouldn't be able to cross. The crisp certainty of our digital world begins to fade into noise. More importantly, AI is hitting a physical energy wall. Today's data centers are set to double their electricity use by 2030, with a single AI chip using as much power as an entire household. To understand why this is happening now, we have to look at the wall we've finally hit. For decades, we've been shrinking transistors down to the width of a few apps. Imagine a library. Not just any library, but one that contains every book ever written, and every book that could ever be written. It holds every possible melody, every solution to every disease, and the blueprint for every conceivable material. Now imagine you need to find a single specific sentence in a single specific book somewhere on those endless, infinite shelves. For our most powerful supercomputers, that task would take longer than the life of the universe, 10 septillion years. But right now, inside a silent, frozen laboratory in Santa Barbara, a machine called Willow just did it in 5 minutes.
This is where the quantum revolution saves us. Classical computers used bits, tiny switches that are either a 1 or a 0, on or off. But a quantum computer uses qubits. Think of a bit like a coin on a table, showing either heads or tails.